All right, guys, this lesson is all about least common multiple. Now, we want to take a look at what this phrase is. We have least, which means the smallest. Common means something that two numbers share. And multiple is any number that number has been multiplied by. So for your lesson today, you have an example that says Tom hits golf balls at the driving range every 3 days, practices putting every 4 days, and goes golfing every 6 days. If he did all 3 activities today, in how many days will he do all 3 activities again? So we're paying attention to the numbers that are in that problem. He goes to the driving range every 3 days, he practices every 4 days, and he goes golfing every 6 days. So we want to find out the common multiples that those 3 numbers share. So the way that we do that is we're going to create a list of multiples. That's why you have some lines on your paper there. So we're going to do it for the 3, the 4, and the 6. So when we're listing multiples, basically it's just counting by that number. So 3, 6, 9, 12, 15, 18, right? I'm just counting by 3s. Now I want to do the same thing for 4. 4, 8, 12, 16, 20. All right. How about for 6? 6, 12, 18, 24, and 30. We are now looking at what number do all 3 of these share? Well, you got to kind of go down your list. They don't all have a 3. They don't all have a 6. They don't all have a 9, but look here. They each have a 12. This is what's called the least common multiple. It's the smallest number that all 3 of these numbers share. So we know that 12 is the least common multiple of 3, 4, and 6. So on the bottom of your page, you know every 12 days he's going to be doing all 3 of those activities, and that's what they were asking us. At the bottom of your page, they have a number line that shows you that. It's split up into days. So it shows here that this is 0 days, 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14. So this is days. So we've got day 1, day 2, day 3. So we know that, let's give these guys an acronym to help us remember. It looks like they used G for golf. So he golfs every 6 days. So that's the G. They use a P for putting, and he practices putting every 4 days. So that's the P. And it looks like they're using DR for going to the driving range. And he does that every 3 days. So let me change colors on those because I think it's going to be a little easier to see. So green is golf, P is putting in blue, and let's make driving range in red. So if we go down to our number line, we know that he goes to the driving range every 3 days. So here's the driving range, 1, 2, 3. Do you notice that these numbers match these numbers? These are just multiples. 3, 6, 9, 12, right? Let's take the putting days in blue. He does that every 4 days. So 4, 8, 12, right? Now we can do it for the days that he golfs, and that's every 6 days. So that would be 6 and 12. What we were looking for with this is what day does he do all 3 activities? And you can see on the 12th day, that's when he does all 3 activities. And we just figured that out by writing a list of multiples. So that's one of the ways that you can help find least common multiple, the smallest number that all 3 of these numbers share. Let's go on to another way to help you find least common multiple. You flip this page for us because I want to be able to look at the back. Now there is another way to help you find this information. It's called prime factorization. I'll write that up here because it's a pretty important word. guys will think back to a couple of lessons ago, maybe even last year, we talked about prime and composite numbers. Now, prime numbers are numbers that can only be multiplied by one and that number. Composite numbers can be multiplied, and you can find they have more than one set of factors, more than one times that number. All right? So we're going to take two numbers and find their least common multiple. So again, we're still working with least common multiple. I'm going to abbreviate it there. We're going to find the least common multiple of 15 and 40. Now we could do it like we did in the first problem. We could write down lists of multiples. This is another way. You guys remember factor bingo in class, right? So in factor bingo, we were listing all the multiples of a number. This is kind of a way to do this. We're going to break this down into its factors. So remember doing this? We called it a factor tree. How can I make 15? Well, one of the ways I can do it is 3 times 5. I don't necessarily want to write down the 1 times that number in this part because it's going to get me stuck on my tree. So I want to get this down to prime numbers. And if you'll notice, I can't break 3 down to anything else because it is a prime number. I would write 1 times 3 and I'd be writing the same number again. The same thing with the 5. So these numbers that you see at the bottom, the 3 and the 5, means I have broken 15 down into the prime numbers that you multiply to get that number. Let's do the same thing for 40 over here. Now I don't want to do 1 times 40 again because we'd be writing 40 and we're trying to get it down to the prime numbers. But because it ends in a 0, I know that I could do 2 times 20. Well, I know that 2 is a prime number, so I can leave this one alone, but I can break 20 down again. How about 2 times 10? Well, I can break 10 down again. 2 times 5. Now, all of these numbers, if you follow down this side across the bottom, because I write the smaller number first, and I do this on purpose, I'm able to find the prime numbers that you multiply together to make 40. Okay? I know this is new. We're going to do it a couple of times. Don't be afraid. If I'm writing down the prime factorization for 15, it is 3 times 5. If I'm writing down the prime factorization for 40, I'm just going to write down all my prime numbers, just like this. Most of the time, you're going to do it smallest to largest, so I'm going to go ahead and do that. So it would be 2 times 2 times 2 times 5. And you can see I got those numbers directly from what we did with those factor trees, okay? So by doing that, we were able to find the prime factorization. So the least common multiple uses everything that we have here. So now we're going to take these two to find the least common multiple, LCM. We're going to take this, and we're going to write them together. Okay, it's what they share. So we have 3 times 5. I'm going to put this in order. Okay, when they have something in common, we only write that one down one time. You see how they both share a 5? Instead of writing down the 5 twice, I'm only going to write it down once. Okay? So the prime factorization of this number is 2, got it from right there, times 2, times 2, times 3, and I only wrote the 5 down once because it's something that they have in common. So the least common multiple of 15 and 40 is right here. We can figure out what that number is, shall we? 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 5. Well, I may be able to do it in my head. You may not be able to. So let's do it on the board. 4 times 5 is 20. 5 times 2 is 10. Plus 2 is 12. The least common multiple of these two numbers is 120. Now, if we had done it the way that we learned the first time, that's writing a lot of numbers to get to 120. Not as much on the 40 side, but check this out, just for reference. If I were doing multiples of 15, 15, 30, 45, 60, 75, 90, 105, 120. Look how far I had to write to get to that number. 40 is not as difficult. 40, 80, 120. You can see how this particular method might be better for finding least common multiple with bigger numbers. Let's go ahead and try another set of numbers like this and see how it goes. So I'll show you again how I do it. So let's do it for 6 and 10. We'll do a smaller set of numbers this time. So if I want to find the least common multiple of 6 and 10, okay? Let's do our prime factorization. Let's make our factor tree. How can we make 6? Well, again, I don't want to use 1 times 6 because that just makes me write 6 again. But I know it's an even number because it ends in a 6. So it can be 2 times 3. Well, I can't break 2 down any farther or 3 down any farther because they're prime numbers. So I'm going to go ahead and circle my prime numbers. The other number we're going to do it for is 10. So if you have 10 and we need to break it down, again, 1 times 10, no need. But it's an even number, so we can do 2 times 5. Now, these are both prime, so let's go ahead and circle them. So the prime factorization for 6, it's already right there, but we'll write it just to be in good practice, is 2 times 3. That's the prime numbers we broke it down into. Okay? The prime factorization for 10 is 2 times 5. Now to find the least common multiple, we're going to look, what numbers do these have in common? So here's the 2 sets of numbers we're working with. Do they have any numbers that they both share? They happen to have a 2. When I'm writing down least common multiple, if it's something that they share, I only have to write it down 1 time. And then I write down everything else that's left behind. So we have 2, because they both share that one, times 3 times 5. Well, what is that? 2 times 3 is 6. 6 times 5 is 30. If we were going to find it the old way, we'd be writing multiples of these numbers, right? 6, 12, 18, 24, 30. Let's do 10. 10, 20, 30. So you guys can see there are different ways to find the least common multiple. But I want you to be able to use both strategies. So both listing the multiples and also using prime factorization to help you. All right, I think that will get you all started. If you have any questions, your parents know how to get a hold of me. Thanks, guys.